Okay, here we are on page 2 of the Chapter 1 review worksheet. So question 8, it gives you that the limit as x approaches c of f of x is 5, and the same limit for g of x is -2. And then letter A asks you, then what is the limit as x approaches c of f of x times g of x? If you know your properties of limits, you know you can just multiply the two limits. Technically what you're doing is you're splitting it into the limit as x approaches c of f of x times the limit as x approaches c of g of x. And that simply equals what they gave us, equals 5 times -2 equals -10. And then the next one asks, what is the limit as x approaches c of 6 times g of x? So you can do this by saying the limit as x approaches c of 6 times the limit as x approaches c of g of x. And that gets us, the limit as x approaches c of 6 is 6, because the limit of a constant is always that constant. And the limit, this limit they gave us is -2 equals -12. Okay, and notice how I kept my limit notation until I no longer had variables. Okay, once I got to all numbers, I could drop the limit and just write numbers. Okay, let's go on to number 9. Number 9 asks you to sketch a graph. And there are really a number of ways to do this one. I'll walk you through one way. So you're supposed to do a graph where it meets certain conditions. The first condition is that f of -2 exists. Okay? So that has to be a function value. We want the limit as f of x approaches -2 to be 1. So as this graph gets close to 2, we need the limit to be y equals 1. So we don't really care what it does the rest of the time. We just want to say that as the graph approaches -2, the y value approaches 1. But it says that this function is not continuous. So why don't we just put a hole here? So as we approach from the left and approach from the right, we're going to -2. Therefore, we can say that the limit is 1. I'm sorry, I said that wrong. So we approach from the left and we approach from the right. We're going towards 1. So the limit works. It's not continuous, so we have that covered. The only thing we don't have covered now is that it says that f of -2 has to exist. So how can we make f of -2 exist without ruining this limit situation and without making it continuous? Well, you can just put a dot here. There we go. F of 2 now has a value. F of -2 now has a value. So we fulfilled all 3 conditions. Number 10